We need to upgrade to GF5 to take advantage of new technologies that OEMs have to incorporate. These technologies are needed to meet the fuel economy standards that are coming along. So things like turbochargers, which make small engines look big. Things like variable displacement engines using oil as a hydraulic fluid. And so GF5 needs to incorporate tests that ensures that the oil can de-aerate quickly and to resist aeration. So we need to upgrade to a new specification so that to ensure that the oil can behave appropriately in these new technologies. Certainly, one of the biggest concerns confronting GF5 right now is timing. The industry is grappling with development of a new fuel economy test. That test is progressing, but there's a very tight timeline to bring that test to completion so that GF5 can come in a timely fashion in the 2011 model year time frame. Beyond timing, probably the biggest issue for GF5 is globalization. ILSAC specifications have up until now tended to be very regional specifications. It's called an international spec, but it's really only used in North America and Japan. Outside of those locations, it's almost non-existent. Europe uses their own boutique OEM specifications, and the rest of the world really uses a hodgepodge of different API and ASEA specifications. So the challenge to the industry right now is globalization of engine oil specifications. You know, an engine built here in North America and shipped around the globe really needs the same oil, whether it be in North America, China, Australia, Europe. We got to have that same oil quality everywhere. And that's going to be the big issue with GF5, is that it's probably going to be like its predecessors of ILSAC, a regional spec, and OEMs really need a global specification. I think the biggest challenges for GF5 from a technical standpoint are probably twofold. First is emission systems or emissions compatibility and fuel economy all kind of in one group. Where as far as fuel economy goes, an oil really can contribute to fuel economy in two ways. The first is the inherent fuel economy of the oil. Things like the viscometrics of the oil provide a certain fuel economy benefit, and also the friction modification properties of the oil. And so it'll be a challenge for GF5, a challenge for the industry to meet the demands of fuel economy that the OEMs have to meet. And oil is a vital part of helping an OEM meet their fuel economy demands. So the oil industry is going to have to get the viscometrics right. They're also going to have to get the friction modification right, and maybe that means developing new, more robust friction modifiers to meet the new challenges that the OEMs have to face. The other is emission system compatibility, and I think we're getting a good handle on that with GF5, where we're looking at phosphorus volatility and how to limit the amount of phosphorus that goes out the tailpipe and poisons the catalyst. But OEMs have to meet certain stringent requirements to ensure that the emission systems that are on the vehicles are nearly perfect for a long time, for the life of the vehicle almost. So those are two big technical challenges to GF5. The other technical challenge is the other aspect of fuel economy. You know, we talked about the inherent fuel economy of an oil, but an oil can also be an enabler for other fuel-efficient technologies. Certainly, turbochargers are one of those technologies where you make a small engine look big by turbocharging it. So you got a very fuel-efficient small engine, but perhaps in a larger vehicle, you need more power out of it, and you use a turbocharger to do that. And oil is going to have to stand up to the high-temperature environment of the turbocharger. We can't have the oil coke in the turbocharger and ruin that turbo. We also tend to use various technologies such as displacement on demand, where we're knocking out cylinders. Perhaps an eight-cylinder vehicle, when the customer doesn't need all the power of the 8 cylinders, we'll knock out 4 of the cylinders and make a small engine out of it. You also use cam phasing to vary the timing of the engine to get more fuel economy out of it. And in both of those cases, the oil is used as a hydraulic fluid. And in that case, it's very important that the oil have good aeration properties, that it resists aeration and also de-aerates quickly when it does get aerated. And so that'll be a big technical challenge for the industry that have to grapple with something it really hasn't grappled with before. We've had foam tests before to evaluate an oil for foaming, but that doesn't really address the aeration issue. And this will be a new issue that the industry has to come to grips with. I think the industry's biggest challenge going forward, 2010 and beyond, are really the challenges that we face today. But it's a challenge that perhaps the oil industry hasn't quite come to grips with yet. And those two challenges are change and globalization. with the new fuel efficiency mandates that are coming out, the emission standards that are coming out, and they're really, yeah, they're coming out in North America, but they're also coming out on a global scale. And oil is a vital component of internal combustion engines. It's no longer just something you put in the engine as an afterthought, but it's really an integral part of the engine itself. And the oil industry is going to have to come to grips with the change that the OEMs are facing, and they're going to have to learn to change quickly along with us. The other big challenge for the industry is globalization. I mentioned earlier that an engine produced here in North America and shipped throughout the world needs the same oil wherever it goes. We can't tolerate lesser quality oil in China just because we're in China. We need that good quality oil there. We need it in Australia. We need it in South America. We need it in North America, everywhere we go. And so the challenge for the industry is to take what is today a very regional specification-driven system where we have ILSAC oils in North America, we have boutique European specifications in Europe, and we have API and ASEA specifications throughout the world. And the challenge is to converge all of those regional specs into one global specification.